Hello, my name is Hamel Salvi, and I'm in a group with Zane Perkins and David Lee Galloway, and I'm doing the video submission for our group. And so we'll start the code right here. So we'll go through everything individually. So we generate the cards at the start of every program. So we count from 0 to 63, and we subtract the largest number, the largest power of 2 from them. So the powers of 2 are 1, 2, 4, 8, 16, and 32 in this case, and each one of them represents an individual card. So we subtract the largest one from them, and once we subtract that value from the number we're testing, we put that we put the number we're testing into that numbers array. And after we subtract, we repeat. We take the new largest number from that until we get to 0, and the initial number is stored into those arrays as we repeat the process. And so, for example, the 8 card, let's say we use 10. So 8 is the largest power of 2 below 10. So we subtract 8, and we put 10 in the 8 card. Now 2 is the next largest number. Next largest power of 2 below 2, which is the new value of 10 minus 8. And so we take 2 out of that, and now that it's 0, we just move on to the next number, which was 11 in this case. And so while we're at it, I'll use 10 as the first example, but I also need to go over how we choose the card order. So we use something called I need to pronounce this correctly, the Durssenfield shuffle, I believe. And the way that works is you take an array of numbers. In this case, we have the 6 cards, the 6 numbers, and you start by taking all 6. You choose the last value in the array, and you swap it with any other value in the array, including itself. Then you cut that off, so now you have an array of size 5. You swap it with anything before or equal to it, and you keep going until you have nothing left to swap, and that will randomize the cards properly. And so let's go on with 10. So the 8 card does have 10 in it, so we'll type 1. The 16 card does not have 10 in it, so we'll type 0. And you can tell which card it is by checking the first number in the card. The 2 card does have 10 in it, so we'll type in 1, and that means everything else will be 0. So 32 card, 1 card, and 4 card. And so the program will get the number we're thinking of as 10. So basically what it does is if we enter 1 or 0, it multiplies whichever number we input by the first number in the card, which is always going to be the card's value itself. And it'll add that to the final product, which we have stored in memory under the, I believe, total, under the name total. And so as we go, total keeps getting incremented by the by the number of the cards that the number is in, until it finally adds up to the true value of total, or the number that the player of the game is guessing. And so we'll do one more run of this card. We'll do 44 in this case. So the 1 card does not contain 44. The 4 card does. The 8 card does contain 44. The 16 card does not. The 32 card does. And the 2 card does not. And so the program adds it up to 44. Alright, thank you for your time. Everything else should be covered in the various other documentation that we had to submit for the project.